Welcome back to food packaging technology. So in the last class, we were discussing about 3-piece can. So it's a part of can manufacturing, and we had seen 3-piece can and what are the different steps that are involved in it. So in today's session, we'll be discussing about 2-piece can and what are the different steps involved in it. We'll be also discussing about lacquers, which are used to prevent the interaction of can contents with the can wall or the can material. Now coming to 2-piece can, it is made from disc of metal. So we have thick metal strips are there. Using cupping machine, it is cut into small cups, which is drawn and redrawing. The plunger is putting pressure on it. The walls, they are drawn. If it is done twice, it is drawn and redrawn. So that is one method of doing. And then after that, the edges are trimmed. These are washed, and then external coating is applied and dried, and over which the printing can be done. And we also apply varnish to give a finishing appearance. And these are again dried or cured, and lacquers are applied on the internal surface. Again, lacquer is a barrier which prevents the contents from reacting with the metal ingredients. Then again it's dried, and here a necking process is given, which is almost similar to the flanging in 3-piece. And then this is palletized. Again, the similar tests are done for this container also. We see whether it contains any pinholes or any fractures or dents, or it can withstand the pressure and impact during storage. Such tests are being done. After it has been cleared, it goes to the packaging section. So the operation of reforming sheet metal without changing its thickness is called drawing. The operation of reforming a 2-piece can into one smaller diameter, that is greater height, without changing its thickness, it is redrawing. That's why it is called drawing and redrawing, that is DRD. The operation of thinning the walls of 2-piece can by passing through circular dies is called ironing. So we have drawn, ironed cans and drawn, redrawn cans. So these are the two processes by which 2-piece can be developed. That is drawn and ironed, drawn and redrawn cans. And drawn and redrawn cans, they have greater heights than diameter. Then drawn and redrawn containers, they are made of steel or aluminum, and they are mainly used for food like processed fish products. So during cutting, the metals are coated with waxes. So this gives lubrication, it enhances the lubrication. And DRD process, it is used to form taper wall flanged cans. Also, it is used to develop into aluminum and steel taper thin wall trays, and which has heat sealed foil lids, which can be used in the food industry. DW cans, that is drawn and ironed cans, these are used in food industry, beverage industry. These are also used for aerosol cans, and these are normally made from uncoated aluminum or tin plates. And drawn iron processed food cans, they are also made of tin plate. And during the manufacture of drawn iron cans, the coils are uncoated because subsequent wall thinning is happening, ironing is done, so which is a severe process, so coating may strip off. So for this reason, we don't do coating, unlike the 3-piece can, where the lacquering is given prior to converting into cylinder and other forms. Here the lacquering or the coating is given in the end. It is not given in the beginning itself because it may strip off during the other processes. And also it is a water soluble material, so it's synthetic material, and it may come off when it is drawn. And application of coating and printing, it is done at a later part of the process. Now 2-piece can, it includes 14 steps. In case of 3-piece can, it is 12 steps, and here it is 14 steps. So we have strips that arrive in large coils. They are thick. These are cupped, they are cut into small pieces, and the cups they are passed through series of tungsten carbide rings, and they are drawn and ironed, and which redraws the cup to a smaller diameter and thins the wall by increasing the height. Trimmers help to remove the irregular edges, and this also helps in getting the precise height. Then these are washed, dried, and these are coated with clear pigmented base, which forms the surface for printing. And then it is passed through oven to dry the lacquer, and then printing is done. and we usually use 6 different colors for printing. Then we apply a coat of varnish to the base of can. It can be done by a rim coater, and then again it passes through the oven for second drying. And inside of the can is also sprayed with lacquer. It is dried in oven, and then it passes through necker flanger, where the neck is shaped, and it is called necked in process, and the tops of the cans are flanged outwards. It can accept the lid, and finally it is the testing process where we check the defects and other properties of the can. Now, if you look at the figure down here, it's a two-piece can which is used to develop the aerosol cans. Aerosol cans, they have long body. We have a plunger which stamps on the foil. So there's a thick foil which is aluminum slug, and it is kept on the mold, and a lot of pressure is drawn. So after successive drawings, the cylinder becomes very thin. So this kind of containers, they are used for aerosols. Again, it's a two-piece can. So can making, it not only includes the development of body, it also includes can ends or lids, which are mechanical double stitch. We can also use aluminum or TFS lacquered on both sides, and this is generally a deformation behavior. Forming lid or forming the ends, this is called deformation, and it plays a very important role. This deformation behavior of the lid, it plays a very important role during filling, seaming, heat treatment and storage, and it depends upon the thickness of the metal sheet and the contour of the expansion ring and the milling depth. To what level it has to be drawn, and what is the ring size and the shape of the container. So these all determines the deformation behavior. Now the edges of the lids, they are stamped on the press from the sheet of tin, and generally it is of high hardness. And stamping it, the edges are shaped to match the upper and lower edges of the body of the can. In the previous class, we had seen how the cylindrical body flanges, when it is passed through the flanger, it has a bending, which is called flanging, and over which the lids come and fit. Based on the size of the flanging, the lids are also designed. And the coating is given or seal is applied around the curved region, and this seal, it can be natural or synthetic rubber which dissolves in water or solvent. It is very important during crimping. So without proper sealant, it is not possible to develop a can lid. So if you look at the figure here, you have a hard metal sheet which is cut into round blank, and this blank, it is formed into ends. That is the start of curling, and the ends, it gets curled, and then in the finishing curl, it is bent nicely towards inside. And this finish curl, it depends upon the flanging that has been developed on the body. So it has to fit correctly in position. This has to be in proper place with the flanging in the body. And in between the finish curl, we put the sealant, and this sealant can be a synthetic or natural rubber. Now let's see it once again in the demonstration. So this is the lid which I was talking about. So if you look at the lid here, there's a bend over here, and this bend, it will be in proper shape with the container. So if this is a container, the lid has to sit properly, and this bend, it will come and fit properly. So how it is developed, it depends upon the flanging also. So this bend and this bend, it is very important. And in between the bends, you will find a rubber. This is a very thin layer. It's a very delicate layer of rubber which can be scraped off using a metal piece, and it helps in sealing and maintaining the airtight container. Since a canning is also called hermetic container or airtight container, and this sealant plays a very important role there. So when you're sealing it, it is sealed along the lining. So this is a water soluble material. When the lid is placed on the body, we pass it through the seaming machine and it gets sealed here. That process is called seaming. We don't add any welding, or we don't do soldering, gluing, or tapping is not done. It is just pressing it and putting it in position, and it forms a hook here. That process is called seaming, and it is also very important. The seam should be throughout and it should be proper for the can product. So seaming is a mechanical assembly of two parts of rigid metallic sheets or foils without the use of welding, gluing, or tapping. The two sheets, they are folded or rolled so that they fit together, and this technique, it ensures airtightness of the closed metal package. The body flange and the curl of the end interlock during the double seaming operation to form a strong mechanical structure. And each double seam consists of 3 thickness of can end and 2 thickness of can body with an appropriate sealing compound distributed throughout the folded metal to form a hermetic seal. Now if you look at the figure here, this was what I was telling you about. So if this is the can lid, then you have lining, which is a rubberized lining, and this is the fold, and this is the can body. So this is the flange which has been developed. So in the first press, that is when first seaming is done, it forms a hook like this. This is a partial hook. This is not sealed properly. And only when it is passed through the second roll, it is pressed and it forms a proper hook. So in the end of the seal, you will get a structure like this, which will have 2 body parts. So if you look at the light blue color, this is 2 pieces will be there. This is from the body, and this dark blue color, it is from the can lid or the can end. So in together, this is a 5 pieces will be there. So, and in between you will get a rubber lining, and this rubber lining ensures air tightness. If rubber lining is not there, air can easily enter into the container. It is more like a gasket in a pressure cooker or a gasket in a piping. It's a leak proof. So that is why liner is important. And these are the different parts of hook. We have countersink and then body hook, just the hook part where the body is forming the hook. Then it is the cover hook. Cover hook is where the lid is forming hook, and seam thickness is the entire thickness of the seam, and seam height will be the entire height of the seams. Seam will contain 2 parts from body and 3 parts from the can lid. So there are some defects which we can see in seam. First one is called V's. It's an irregularity in the double seam due to insufficient or no overlap of cover hook with the body hook, and usually it happens in small areas. So when we are doing seaming, if there is the double seam is not formed properly, that is cover hook and body hook, they are not sitting properly, then it forms V's. A jumped seam is a portion of double seam that is adjacent to the juncture of the soldered side seam that is not rolled tight enough. So a jump seam, it is generally seen at the part where the can body is welded. So there the thickness is high. Sometimes it happens that the seaming doesn't have properly. So that part may jump over. So that is called jump seam. Then we have dead head. It is an incomplete seam. It is caused by the chuck spinning in the countersink of the end during the seaming operation. And this seam is also called spinner, skidder, or slip. And we have another seam, false seam. That is a seam, a portion of seam that is entirely unhooked and which is folded cover hook compressed against the folded body hook. So it is that body has formed a separate hook and the cover has also formed a separate hook. So this is again a defect that can happen in the seam. Now can surfaces, it need to be treated with some coating so that it does not react with the contents inside. And sometimes this coating also given on the external surface. So this is called lacquering, and it increases the shelf life of the metal can, as well as it prevents the solubility of cans under high pH or low pH, and also in high concentration of sodium chloride, then reaction with sulfur from amino acids. So for these reasons, a coating is given on the steel or aluminum coins. These are generally organic coatings. But nowadays we go for synthetic resins, and these resins, these are more flexible and they help in high-speed manufacturing. There are different types of synthetic resins, oleoresinous compounds, which can be natural waxes, natural oil-based coatings from fossil gums. We can also have synthetic resins like acrylic, epoxy, phenolic, polyester, and vinyl resins. Now these resins, they can be acid resistant or sulfur resistant, that is AR or SR. We select or we choose the lacquer based on the contents of the can. So we use acid lacquer where the acidity of the content is very high. For example, pickles or vegetables or fruits where the acidity is very high, that is below 7. In such cases, we go for acid lacquer, that is AR lacquer, and we go for sulfur lacquer or sulfur resistant lacquer in case of food products where sulfur content is very high. For example, the fish and meat products where the amino acids contain sulfur, this sulfur may react with the metal components and form iron sulfide and hydrogen sulfide. The hydrogen sulfide will give the foul smell, whereas the iron sulfides, it will form the blackening of the contents, or black layer will be formed on the surface of the can content. So there we use sulfur resistant lacquer to prevent such kind of changes. Now these are different types of lacquers. Their application properties, corrosion resistance, ease of fabrication, ease of application, and their universality in food applications, then organoleptic properties and appearance are discussed in this table. So lacquers, they are of different types. Epoxy, these are synthetic lacquers. Epoxy, acrylic, phenolic, vinyl organozole, polyester laminates, polyester coatings, and oleoresins. In epoxy lacquers, they are universal golden coatings. They are generally used in 3-piece and shallow drawn cans, and they are most widely used coating. Even acrylic coatings, they are universal coatings, but they are generally used in beer cans or beverage cans. Then side seam strip in high solids form welded cans. So in such cans also, the acrylics are used as lacquers. Phenolics are used as lacquers in drums and pails. And vinyl organozole, it is used as lacquer in drawn cans, easy open cans, and it is often used as a mixture of epoxy and phenolic base coat. Then polyester laminates, these are used in shallow drawn cans and easy open cans and standard ends. Polyester coatings, it is given on internal and external coatings of 2-piece and 3-piece cans. It is usually used in meat, fish, and vegetable industry. And oleoresin lacquers, they have limited use, and initially these were applied in all types of cans, but then nowadays they are limited in use. And coming to the properties, epoxy lacquer, it has high molecular weight and it is cross-linked with phenolic resins or anhydride hardness, and it's a very good chemical resistance and fabricability. And even the acrylic lacquer, it has high molecular weight epoxy resin, and it can be cross-linked with amino and acrylate resins, and it is a waterborne coating. Phenolic, however, it's a low cost, poor flexibility, but it has excellent resistance to aggressive foods, which is highly acidic. And vinyl organozole, it is PVC dispersed in an appropriate solvent and stabilized with low molecular weight epoxy resins. And polyester laminates, it is extrusion coated or laminated film of polypropylene, polyester, or polyamide, and it has good fabricability and it is resistance to corrosion. Polyester coatings, similarly, it can be cross-linked with phenolics or amino resins, and again it has very good chemical resistance and good fabricability, and these are the reasons why it is adopted in food industry. And whereas oleoresins, these are synthetic modifications of natural oils and fatty acids, and they are golden colored, but these are cheap actually, but then they have limited use. So you can see the corrosion resistance here. The first epoxy is resistant to corrosion, and again we have phenolics which is resistant to corrosion, and the other lacquers, they are not resistant to corrosion. But then polyester, it is medium type. It is not a very good resistance, but then it can resist some of the corrosion. Then ease of fabrication, vinyl organozole, it is easy to fabricate. Even polyester laminates, it can be easily fabricated. Polyester coatings, oleoresins, they can be easily fabricated. Then ease of application, epoxy, acrylic, they can be easily applied. And polyester laminate, polyester coating also can be easily applied. And we can use epoxy and polyester laminates or polyester coatings in food industry. And when it comes to sensory properties and appearance, epoxy is very good looking and it is widely accepted. Vinyl organozole and polyester laminates are also wide acceptance because of its good appearance and organoleptic properties. So with this, let's wind up for this session. So in this session, we had discussed about 2P scan and what are the different methods by which 2P scans can be developed. And we had seen the different steps. And we have also seen how the lids can be developed from the metal sheet, and what is a hook formation, what is a seaming, and how important seaming is. And then we ended with lacquering and different types of lacquering and their properties. So let's wind up for today. Thank you.